Thank you for coming to this presentation. My name is Rafael Saavedra. I'm a VP of Engineering at RightScale. So what I'm going to talk about is, RightScale managed by RightScale, more or less what is the structure that we use. And then the systems that we have. We have basically a meta production, that is the system that controls the production system. Then our production system, we have several staging systems that we use before deploying. And we have also development systems as well. Then we're going to give you a quick overview, very high level, about the production system that we use. Then a Latin phrase that basically means who watches the watchman. That is, all the infrastructure that we have that basically helps our users run the deployments, well, we need to do the same thing for ourselves. And that goes into interesting problems because if you have servers that basically are monitoring the servers that you use to monitor, when things go wrong in the cloud, you have problems about being alert and things like that. And then we basically show you about what is deploying RightScale, best practices, how we do it, more or less, the lessons that we have learned about deploying efficiently and effectively on the cloud. And then also some subjective comments about what we know about RightScale and so on. So to begin with, well, RightScale is a cloud management platform. What it means is that there is the cloud, and RightScale basically lives there. RightScale is, as many of your applications, is just another deployment with a lot of servers that basically all of them live in the cloud. And the purpose of RightScale is to manage deployments from customers. So what people use basically connect to our dashboard, and they use it so that they can basically get access to the servers and do things that they need to do as system administrators. However, the same thing as managing our customers' deployments, we can go and also manage systems that are our systems themselves. And in particular case, we use RightScale so that we launch the RightScale staging system and we manage them. And similarly, people who are developing from the next release, normally what they have to do is to boot a RightScale and start working on them and basically doing new features. And one of the things that they can do on that development system that's been managed on top is to put a deployment and continue and so on and so on. But at the same time, we need something to manage the RightScale production system. We need basically to access that. And what that means is that we need another system, but that basically lives outside of the cloud, may live in a completely different cloud, but it has to be in a way independent. And we use that to completely manage the RightScale. So this is just something that looks exactly the same as if you have used our site. That is basically a deployment that contains some of our servers. And in the same way, we use the same concept, servers, and we have our servers, our quick monitoring graphs that allow us to look what is the activity in the different servers. And this is happening in real time. So in fact, 10 minutes before I was here, I was chatting with some op guys and basically discussing some changes that we wanted to do. And it's very nice to really live in the cloud because you continue working when you're not working in that respect. So going back here, what we have is a multitude of RightScale systems. And I can classify it at least in 4 classes. We have the meta production that basically currently lives outside of the cloud. And it's only used to manage the production system. So it's a very, very little RightScale that in a sense had maybe 3 or 4 accounts. It's only our accounts. And we completely separate the databases so that it's secure, so that we don't have to any problems in that respect. And we have the production system that most of you are familiar with. And around it's reaching something like 200 servers. And a large fraction of them live in DC2, US West, because, well, it's the cloud that is the oldest, the most stable. It offers the most functionality, and also has the best, basically, characteristics at this point. Now, we also have servers in every cloud we support. I think I forgot that piece of the sentence. And that means that we use these servers mostly for when latency is critical, well, or we want information to be stored in the cloud itself, we do that, but they're still managed through our production system. And in addition, we have a few staging systems that are used for integration and QA. And the wonderful thing about the cloud is, well, you can have as many as you want. Okay, you have to pay for that, of course. But it gives you a lot of flexibility in terms of sometimes we need different branches that we are working on. For example, Amazon is going to release a new feature, and we know that it's coming, but it's very difficult with Amazon to know exactly when. So what happens is that we have a good relationship with them, so we try to go live with support on our side as soon as they go live, but they don't tell us when. So that basically provides some challenges, because although we know that it's coming, we have to be ready, and sometimes what we have to have is different branches, and we have to test them actively. And in the cloud, it's very easy to suddenly launch a staging system that contains these different branches and to be able to test them and do QA on them. In addition, we have many development systems with simplified configurations. Our system is starting to be quite complex, and what it means is that developers, in order to test interactions between different clouds, well, they have to put a significant amount of resources in order to test something that is realistic. And I remember 3 years ago, we were able to run everything on my little laptop. I was able to do development and everything that we needed, run the daemons and so on, and connect to Amazon. And now it's becoming more of a challenge, and basically we need to do everything in the cloud if we're doing some development. Well, obviously, there are certain kinds of work, like UI work, that is easy to do it on your laptop because you don't have to interact at all with the rest of the world. So I don't think I mentioned this. If you have questions, please interrupt me, and I'll be happy. Yes. The question, I think, was why we're not using other regions apart from the US East, correct? Yeah. No, we are using them. We are using them. I think when I said we are running servers in every cloud that we support, that's what I mean. The regions, basically, they are independent clouds. Yeah. And we have servers, we have RightScale servers running there in order to basically, for example, monitoring, we store the information on the actual regions themselves. We also have auxiliary systems that I'm going to show you. When you boot a machine, you need to download packages. And what we have found is that the repository of packages are a little bit flaky. So it's not nice when people try to launch server templates and images that are pretty solid on RightScale, and suddenly they are not able to boot those servers because some of the packages are not available because the mirrors basically are not there. So what we have done is we mirror those repos, and we have servers on the actual regions with the mirrors, so that when your servers boot, they go directly to resources on the same cloud in which you are basically booting. That answer your question? In a way, it's half and half. We monitor the different regions within themselves, but in the end, we have some centralized system for alerts right now, and that's on the US East. Now, we do that only for simplicity. At some point, it was simpler to start to do it that way. However, we really want to decouple as much as possible the different regions. And I think in a couple of months, we're going to have independent systems, so that if one of the clouds, basically, or regions go down, the system can continue working on. Now, I think it's easier said than done. We still have a lot of work to do in that respect. So basically, the RightScale platform has basically had to support this very significant growth in usage that we have seen on our servers. And you can see that I'm not using units so that I can be as sketchy as possible. But as you can see, the slope is having to increase significant. And that basically has made us basically scaled. Not only you as customers are scaling, but we have to scale as a result of that. Now, some interesting numbers about RightScale is that we have launched, I think we have said that before, 1.65 million servers through RightScale. We continuously monitor more than 60,000 servers that basically are running in either an EC2 or on private clouds. And every day, just rough numbers, 2,000 arrays basically are resized actions are executed. And this is automatic actions that basically grow some array, launch more application servers, or basically shrink the array as a result of maybe less load. With 30,000 alert escalations are triggered. That means that servers in the deployments for our customers suffer some kind of change in behavior that triggers some alert, and we have to basically handle that. That means that 20,000 email escalations have to be sent to our users. In some cases, some users receive thousands of emails. They don't respond to them, and we have strong opinions about that, but well, that's what it is. And to give you also an idea of the volume, we basically exchange 9 terabytes of monitoring data with our servers, and these are our customer servers. You can imagine not all of these 60,000 servers that are basically tracking send monitoring data to us. I would say maybe a third of those are the ones that are using server templates and are configured, but that's a significant amount of information that we have to receive and process. And 1.6 terabytes of login data is sent to our servers. So just a very simplified view of what RightScale is. We have basically at the front, we have some front ends, as many applications. Behind that, we have basically the main app that consists of 2 pieces, the dashboard and the API servers. And behind that, we have some number of databases, master slave and other read databases and so on. And in addition, we have daemons, and we have a collection of a lot of daemons. It's something like maybe 20 daemons. Normally, we have a daemon for each of the clouds. What they're doing is polling the cloud and basically trying to find out the state of all the servers for our customers, so that if you terminate a server either from RightScale or completely outside of RightScale, we detect that as soon as possible so that we can update your dashboard and you can see the information immediately. Similarly, we have to do the same for every region. We have daemons that also take care of, for example, the alert escalations. They are basically looking at the work queues and making sure that we send the emails on time, that we raise the alerts, and so on. In addition, we have some systems that are there to help manage your systems. We have a lot of systems dedicated for monitoring, and we also have for logging. And we have the other systems for basically when you launch a server, we mirror a lot of repositories so that we can make sure that you're gonna have the information when you need them. And in addition, we have other systems that are either specific or are just in alpha or in beta, and there are plenty of those as well. Okay. So what is our users are doing? And this is just a very high level. So we have different components. Is the dashboard, the API, the monitoring graph that you see. I think you saw them here. This is the graphs that we're updating real time every 20 seconds. And we also have the notifications. I don't think here I'm showing them. There may be maybe 1 or 2 notifications that show what is the actions that are happening on your system. So what's happened, normally what we see daily is that 85% of the requests have to do with just updating graphs and all that information so you can have a good view of your systems. 8% represent notifications of events, and the API is 6%, and the dashboard really what people normally see is only 1% of the request. In terms of volume, well, in terms of volume it's a little bit different. The API and the dashboard represent 26% of the volume, while notifications is less, and monitoring is the lion's share of what's happening in our systems. As I said, we eat our own dog food. We make sure that we are normally the first ones to use the features, to test them, to see whether they work or not. And production servers are organized into independent deployments. We have core servers that basically consist of front ends, API servers, databases, daemons, and so on. And this is just a slide, but it's just taken from here. We make extensive use of the inputs to configure. We try to follow our best practices, and that means that, if you remember, there are 3 levels of inheritance in terms of inputs. You can set inputs on the template. Basically says and examples of templates could be maybe a template for a front end. Another template could be for the app servers. Another one will be maybe for the MySQL. And the idea is if you set the values for some parameters there, every instance that is going to be launched using this template is going to basically receive the default value. However, because it's not the same to configure a database for a production system than for a staging system, we have a way of overriding these template inputs with deployment inputs. And similarly, once you have 2, for example, MySQL instances on a specific template, one may be used as a master, the other one may be used as a slave. So there's also the way to override the parameters so that the server itself can basically say, hey, I need this parameter to be changed. And here I'm showing you the deployment in which we use to configure our core servers, API servers, and most of our systems. And you can see there are a lot of them. But it's extremely convenient because just with a single page, we can configure something like 50 servers and making sure that all of them get a consistent settings so that everything is the same. And if we have to launch 10 more servers of the same thing, we can do it, and there are no surprises there. From the very beginning, our philosophy is you don't want to tailor your images to the server. You have to rely in a very solid image that you use all the time, that you know how it's basically what it has inside, and then all the configuration comes on top based on server templates. And as you can see, we do that so that we use the same image that we know that works perfectly, and only when maybe we launch a new server and we try to test a new image, we do changes there. In addition, we use extensive user security groups. We make sure that only the servers that need to talk to each other have access to do that. We restrict every access to a report, and we basically group the servers in terms of who are the databases, and the databases should only be allowed to be talked by the app servers. The app servers can only talk to the front ends and to the databases and so on. So we make sure that we enforce those restrictions. It's been surprising to me that a lot of our customers are, in a way, very liberal in the way that they use security groups, and we try to be proactive in telling that, but it's something that we ourselves need to be very, very strict. And we also make extensive use of server templates, and in every release, we produce a completely new version of the server template so that we have a completely snapshot of the environment that we were running before, and we can basically go back, especially for staging, and reproduce exactly the conditions that we have in production. Monitoring, alerts, and escalation is something that we have put a lot of effort, and as you saw in the talk in the morning, most of the ideas come from our actual use in them. And we use them to monitor everything that we think that is relevant. We put alerts to all these metrics, either the size of queues, the iteration times that daemons take, the amount of work that each of the daemons is doing, the rate of work that they are producing, the throughput. And if everything is a little bit out of whack, we basically receive alerts. We also try to be very proactive in classifying the alerts in those that are warnings, things that we may want to know about, but we don't want to respond immediately, and critical alerts. Critical alerts, basically all of us receive an alert, and the consensus is we have to respond immediately and basically find out what is the reason. And we follow what we call the no broken windows policy, and that is no alert that is critical should basically be, should stay there and continue ringing. The condition has to be removed. And the condition is not just, well, if something is critical, you have to remove it. But in other cases, it may be that maybe the amount of swap space that is being allocated to an instance has reached some threshold. And well, that's not critical because it's going to take maybe several weeks before there is a problem there. But again, our policy is to say, well, either we have to reevaluate the alert or we have to do the changes so that this alert is not going to continue ringing, so that you can actually distinguish when something rings in your beeper or in your phone, what is really the things that are important. Again, is the need to monitor the monitoring system. It has presented some challenges, because here what has happened in the past is that we use the same servers to monitor in themselves. And that was fine until something happened, for example, in EC2, and networking was not working. So suddenly, all our customer servers start complaining, but the system that's supposed to deliver that and to detect that was also experiencing the same problems. So we have some issues about not being aware that there were some problems there. And we knew what was the solution, but it's not easy to basically roll out solution while you maintain the system operational. And we have done that, so now basically our monitoring system that monitors the production system lives outside. There are still some minor dependencies there that we're working on removing. And given the amount of servers that we use for monitoring, it has been a challenge because instance and EBS failures has given some headaches. It's normally maybe once or twice a week in which something happens in one of these instances. Either the instance fails or the EBS volume is not responding correctly. So given the number of servers that we have, it has done some active amount of work to basically be able to replace these servers, to be able to reroute the information from the old server to the new server and to keep running. So this is something that has kept us awake many, many nights and that we have to continue working on. I think, as you can imagine, these are examples of the heat maps, and we're using them, and I think they are very, very nice. Here is just showing 100 servers that are basically showing their load, and what the two different colors is just there to help you distinguish between groups of 10. Each of them has a different scale. One is going, maybe it's a little bit difficult to see, but one is going from green to some kind of orange, and the other one is going to more deeper red. But the nice thing is that graphs like these allow you to, in a snapshot, to see what's happening. And if there is something that is completely out of whack, then immediately you will see it there. Okay. Now, what are our favorite RightScale features? And I think I mentioned that before. Right images, it's basically the most important is never again the need to build custom images. And we really, I think, even customers who like RightScale, who have basically accepted the principle that images should be constant, they tend to, in some cases, they need to resist the temptation to create a specific image, either because they believe that they need to boot faster, or because they believe that they have to do some special tweaks. For us, it's something that we never do. The image is something that is base. It has to be very pure. And once you accept that, you don't have to worry about surprises in your images. I mentioned, again, input inheritance makes it so easy to keep in sync the configuration of dozens of servers. And it's something very, very nice that you can worry about the high level of managing your servers, not about configuring themselves. Server templates is something also very powerful. It's very easy to reproduce configurations either in production, staging, and development because you know exactly how you configure things and what things you contain. That means that we always resist the temptation of going to a server and make changes there. We never do that. We may do it in the test environment just to verify that something works. But once we know that something works, well, if we want to do it on staging or want to do it in production, we go and basically write a new recipe or a new write script. We put that into a server template. We test the server template, and then we use the server template itself. And the way we normally do that is that we launch an instance from scratch and make sure that it basically boots completely the way we want. We don't rely and say, well, this server that is running there is fine. Let me just add the change, and next time that I have to launch, I hope that it's going to be exactly what I wanted. Yeah. Another thing that is also very nice is the library. There is always an example of something new, and that can be adapted to our needs. I think if you go and look at the write scripts, you have a lot of examples of either things that we have put together or things that our customers and our users are starting to contribute. And for example, something about main cache, you can go there and if they are basically free for you to use, you can adapt it to your needs. So that's also very nice. And monitoring, well, monitoring I think is great. It's easy to use, and if you know how to write a collect D plugin, you can just write it to measure anything that you may want in your own servers, and it's very easy to plug in so that you can see the graphs on the dashboard, and we do that extensively. Now, what are our not favorite features? And there are some of them. And well, server template inputs, they are very powerful, But what happens is that you start building these server templates, and then you want to configure them in many ways. So, okay, you want to configure them, add an input, and then you have to decide, is this input mandatory, is optional, and you have to basically describe it. And after maybe several iterations, you end up with a server template that has maybe 20 or 30 inputs. And when someone new comes and has to use it, it's a challenge to understand what is really mandatory, what is not, what parameters shall I set in the template itself, which ones I have to set in the deployment, and which in the server. So sometimes that gives us a lot of headaches. I think we need to invent something better than that. Similarly, revision management, that is, being informed about new templates or new write scripts, new versions, it's something that it's painful. I think before we introduced the library, we have a method that was very simple. It was just a set of lights that were yellow, and they told you, hey, there is a new version of this write script you may want to update. With the library, it has become more difficult, and we ourselves experienced that sometimes there is a new revision of a template, and we're not aware of that, and it's not easy how to find it. And the last thing that we may want to see some changes and improvements is alerts. They work pretty well, but they're not easy to configure, especially custom ones. I think that someone who hasn't been using RightScale and extensively for a long time, when they're exposed and you explain to them what is the concept, it takes a while for them to understand. And I don't think it's intuitive. They may learn to use it just by practice, but they are not intuitive. And we have to come up with something better in that respect. Okay. Now, I want to talk a little bit about best practices. How do we actually upgrade RightScale? And I'm going to take you to the steps. And these things for some of you, may not be new. But I think it's something that has made our life very, very easy, because in a way we have tried to take advantage of what the cloud provides. And the principle is we avoid upgrading existing servers. Instead, we launch fresh ones with new software. And we try to do that, even when that takes launching maybe 20 servers. We do that. We go through that process in every release. Obviously, sometimes that's not possible. You have 100 servers of some type. You're not going to basically go and launch another 100 and basically manage that. It's just not convenient. Hopefully, in the future, we will have enough automation that will be a reality. And now, the nice thing is that given the way the cloud works, the cost of duplicating servers is minimal. Maybe you will need to keep them for 1 or 2 days, but the price is very small compared with the flexibility that it allows you to basically have 2 full deployments that you can switch back and forth. So the idea is the old servers can take over in case of something goes wrong. And also we launch additional slaves to capture recovery points. So the idea is to say, well, if it's easy to launch servers, launch as many as you need. Don't spur that, and try to basically be as flexible as possible. One slave, basically we use it to continue replicate it in case the master fails. We can always basically fail over. But the other one is frozen at key points, so that if something goes wrong, we can always go back and we can basically recover from that point. And of course, don't forget to take snapshots in case of major failure. So what I'm going to do the rest of the time is to show you how we do that. And it's very simple, but I think it illustrates more or less these principles. So let's assume, in a very, very simplified way, that you have your simple 3-tier deployment in which you have your front ends, your main application on your databases, and this database is just a master and a slave, and the slave is replicating. And you need to basically upgrade the system. So the way you do it is, as I said, you launch new servers that contain the new code. I'm trying to illustrate that with blue. You configure them. You can make sure that they are working correctly, and you have them there. And then after that, you basically connect them, but preventing any traffic, to the databases and to the front ends. And then what you do is you launch a second slave, and you start replicating on that slave. And the purpose of this slave is just to serve as taking a snapshot at the moment that you are going to make the transition from your previous release to the new release. So once you have that, then you basically start your maintenance window, and what you do is that you cut access to the site so that your users are not interacting to your site, but your servers continue to talk to your database so that you can drain queues. You can basically, all the work that is still going on continues to completion, and you do that for some amount of time until you consider that you are ready to go. And after that, you basically stop all access to the database and make sure that nothing is happening, so there is no change of state at all. Once that's the case, what you do is we stop replication of one of the slaves. So at that moment, what you have is exactly the state the moment that no activity was happening in your database, and that's the last point of your previous release. Then you take a snapshot to make sure that in the worst case that Amazon or whatever cloud melts, you still have basically something that you can recover later on. And after that, you are basically ready to do the switch. And the way you do it is you connect to the database and you update your schema, you do all the changes that you have to do, and suddenly your database happens to be in the next release. It's ready to be put online. But you still have your database in which you stop replication in case you discover that something went very wrong and your database somehow is not in the state. You can always recover by using that slave. If everything goes well, then what you have to do is you can reconnect the servers. Maybe you can restart your daemons. They can start basically, you can do your testing. If you have a front end, as normally we do, we basically launch a front end that is only accessible by us. So we can do some testing and make sure that everything is working fine before we allow users to go and use the site. And then, well, if everything is up to where it should be, then you can open the access to the site. But you still have the old servers ready to take over, and you still have the old database, at least a slave, in which you can recover. Hopefully, by the time you open the gates, that's not going to happen because, well, there is some transitional state that you were not able to recover. Okay. And then you may leave your servers running for maybe a couple of days. You want to do some analysis, or you want to make sure that things are going well. But at some point, you just disconnect your system, and maybe some later, you basically terminate your servers, and you can continue putting your snapshot there so that just for the record.